So I'm presenting my screen. I hope my audio and video is clear for you so that I can start my presentation.
Yes,
Okay, right.
yes, sir.
So
Your
very
audio and video is clear.
yeah. So very good day to everybody present here, and a warm welcome to all my dear colleagues and participants of this valuable international conference. So this is my topic of concern. It is low cost visual support system for challenged people, and I would like to share this information especially for my dear colleagues, staff members, young researchers who have taken pains to attend this conference. And you can reach me at dr.christoananth@gmail.com. So before beginning the session, let me thank God for giving me this golden opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. So, this is what we are going to discuss at a glance. We are going to go for a short introduction, and then we discuss about the importance of AI, and then I discuss about some of the key objectives of this research paper. I bring out some literature survey, some papers which I have referred through, and of course, the proposed system I would be sharing you with the Raspberry Pi architecture, the significance of Raspberry Pi in our proposed framework, and then I'll discuss about the block diagram of the proposed visual aid system. Then I discuss about the single object detection system, about the ultrasonic sensor distance, and then I discuss about detecting multiple objects with various confidence levels from a single frame. And then I would give a simulation result, the output of the location tracking website, and also the location of the user with respect to the latitude as well as the longitude. Finally, I summarize my presentation with some references, and if time permits, if the jury permits, I can show you a short video about the working model. So this is the introduction. As I can tell you with this proposed framework, this is basically onto the innovative visual aid framework. So definitely it is going to aid the or support the blind people, definitely, which takes a form of glasses. Okay. So we have a complicated algorithm processing which is going to consume low end computing power. So here we are going to use Raspberry Pi 3 model B plus. So definitely we will have the advantage of advanced dual detection and distance measurement capabilities. Also we have camera as well as ultrasound sensors in order to capture the input. In addition to it, for the case of location tracking, we use GPS based location tracking for a navigation system. Definitely it is provided by the IoT, Internet of Things device. So definitely with this advantage, we are going to have better access and navigational ease to the blind people. So this is definitely AI plays a vital role. Definitely in the forthcoming 5 years, we are going to experience AI in and around the world. So here am I to discuss the development of intelligent machines, which is considered as a critical component in CS, mathematics, and information technology. So if you access to large in amount of information, definitely we can build this AI in YAML platform. So maybe in the case of the self-driving cars, or maybe chatbots that you use, personal voice assistants, and high-performance computer systems, definitely AI plays a vital role in our cutting-edge technology. So these are the key objectives of my paper. So we are going to get much information about the moving barriers because it's not something fixed. We are going to go for something transfer on and on from a distance to the readership, generally with the case of the integrated real-time reading assistant. Definitely, we are going to recognize objects in a live video stream, and we are going to offer the output to the user in full resolution, almost like we get the accuracy of around 98%. And the user's location will be tracked by the GPS, and generally it will be reported to the guardian via the IoT. So here is a literature survey. We have a smart glass system which is going to detect and recognize the road signs in real time. Of course, it is a real time. Even in the public restrooms, like maybe restaurants, hotels, or maybe bus stations, we have a smart glass system which is going to recognize this in real time. Also, we have in this system we have a tiny, lightweight, portable, and easily adaptable to maximize its utility. And in order to support and help a blind person, generally by simply reading out the road signs might not be sufficient, but it still feels some insecure, or maybe in a not a very familiar scenario. So maybe there might be possibility that the sign will not be recognized in the systems database if it is not actually recorded in the systems database, because the public signs definitely it will vary from location to location, from city to city it might vary. So if a sign is not recorded in the systems database, definitely it will not be recognized even. So that's the reason we are not giving some comfortable scenario for with the case of smart glass system for the blind people. And visual impaired users also, with the context of our navigation services, maybe they tend to use this smart glass system. Maybe when they move around, like from objects maybe to places, definitely with the interconnectivity, definitely it allows to make them choose a better travel decision with their ability to communicate. And this cyber physical system definitely has a component where the human definitely controls the ability to think, the ability to move, the ability to take decisions, even the ability to communicate. And specifically visual cues and distance sensing of physical objects as a line of sight interactions, definitely with the location to location it changes. Also with the case of tweets that we get with the case of social media platforms, we can generally evaluate, as a blind person we can generally evaluate the current situation and the scenario. Also, we have ETAs, that's a existing system. We have innovative ETAs, electronic travel aids, in the form of spectacles. Definitely will be having some travel difficulties, still there is adequate and safe training, but still based on the usage of sensor, the battery usage, and the ultrasonic sensor that we tend to use in ETAs, definitely on the positive side it helps in recognizing small and transparent barriers. But even for the fully blind people, in order to make a decision, it's still not convenient. And here in ETAs, we have visual augmentation, where we have augmented reality technique. So we have still a prototype, a hardware model, where we have a pair of glasses, and then we have a variety of inexpensive sensors and components even. So definitely it's accurate and very efficient even. But still, if you talk in the case of the connectivity, or maybe from when you move from location to location, or maybe the comfortable scenario, we are not getting with the ETAs. So this is a proposed system. So this is actually a visual aid, which we have analyzed the disadvantages of our existing system. So we have taken the accurate as well as reliable means to actually support the visually impaired individual. So definitely, if this person is wearing the glasses, he can attach the visual aid to use them, maybe in the indoor or maybe in the outdoor navigation systems even. Still, it's tiny, it's lightweight. Definitely, it's completely hands-free method even, the device even. So this technology definitely it will be supporting the blind individuals. Definitely in real time it will be given a verbal feedback even with the case of distance measurements. We are getting some accurate distance measurements. I have discussed this much in the paper. So the system's design is simplified, and definitely even with the case of GPS location, we can be able to easily send messages to the family members or maybe the mutual friends even using IoT. Also, while talking about the price, the economic features as well as the probability, it is considered as the most significant one. We tend to use a Broadcom processor, which is actually BCM2837 quad core 64-bit processor. So we have the RAM, the internal as well as the external memory, 1 GB of RAM, wireless LAN we have, and then we have BLE, Bluetooth low energy module, and then of course we have the big board. Okay, so definitely with this features, along with the added advantage of 100 base Ethernet GPIO with like 40 pins. So at the back of the device we have like four USB 2 connections, and then we have 4-pole stereo output, and definitely we will have a composite video input even. So with this full size HDMI connection that we have over here, we can better connect this Raspberry Pi to the display of our choice. We can choose the corresponding display event. And for example, if you have decided not to choose the USB port, maybe you can connect the camera directly to the Raspberry Pi, and by putting it into the camera connector on the board, you can definitely get the output. So the switchable micro USB power source that we use over here, that has a maximum output of 2.5 amps, and definitely we will have a on off switch even. So this is the Raspberry Pi architecture I'm talking about. So this is what we experimented with these results. And then about the significance of Raspberry Pi, definitely Raspberry Pi, everybody, that it is going to help the person in charge of the virtual aids in a proposed work. And definitely, in addition to the detecting the obstructions, the hindrances, so definitely the sensor is going to communicate efficiently with the visually challenged individuals through the headsets. And the USB camera is going to identify items in the local surroundings, and it's going to convey that information to the disabled individual who cannot see them. So using this proposed technology, even the detected object is displayed on the monitor, and definitely the GPS modem communicates the location information of the individual who has been visualized. So using this technology, we are creating a very efficient object identification and tracking framework even. So we can run in real time in the Raspberry Pi microcontroller board. Uh, to better assess this one, to better assess the tracking operations, we are carrying out RCNN based approach. It is region convolutional neural network. Okay, so with the case of object detection, definitely we will have Python into it. So that's been integrated into the embedded system. We have TensorFlow, Keras, text to speech libraries even, to better assess the audio video sources. Like we have PY, TTSX3, or maybe GTTS, or maybe eSpeak even, which are considered as open source platforms. So this is the block diagram of our proposed visual aid system. We have power supply, ultrasonic sensor, USB camera. We have the Raspberry Pi architecture, from where we feed it to the monitor. For the location tracking, you use the GPS modem, and with the headset, you are going to better analyze the audio features and communicate well. So definitely the camera's data was collected using the ultrasonic range finder. We have HCSR04, which is placed underneath it. So definitely to use the ultrasound module, the 4 pins are connected to the Raspberry Pi's general purpose input output ports. We have GPIO, and then here the pin 2 was assigned to the VCC port, and pin 6 was assigned to the ground port. Okay, and here pin 12, what you call to be GPIO 18, was connected to the trigger signal, and pin 18, GPIO 18, is connected to the echo signal. So definitely the output signal of the ultrasonic sensor, you call it the echo signal, and if this sensor is not active, which means it is going to generate a low 0-volt signal. So when the sensor is active, it can generate a high 0-volt signal like 5-volt, and one of the GPIO pins was configured as an output, which resulted in the sensor being activated. So this proposed system, we use the single 10 second pulse that's required to turn on the HCSR04 sensor and its associated modules. So when the subject responds with an echo response, so the sensor emits 8 ultrasonic bursts at a frequency of around 4 kilohertz. So definitely we will get the better echo response from the subject. And definitely it is going to lead the sensor to emit 8 ultrasonic bursts at a frequency of 4 kilohertz. So definitely which will cause the sensor to generate 8 ultrasonic pulses at a frequency of 4 kilohertz. So that's a great thing that we achieve at a very short duration of time. And the trigger pin is held high for a total of 10 seconds before being reset to low. It is going to cause the trigger pulse to be generated. And because the sensor detects reflected signals from a long distance, so when the pulse travels from a longer distance, so it's going to return the sensor's echo parameter on its controller, which is being increased by the sensor. So here the value of the output variable changes from 0 to high, that's 1, and it's going to remain 1, the high state, for a duration of the echo pulse. So the speed at which the sound travels is determined by several elements. Maybe we have the medium where we tend to conduct this experiment, and also the temperature of that medium. So the operating speed will be like 343 meter per second, which is the same as that of the sound speed at sea level. So this is the single object detection system. So we are able to achieve the detection system with cell phone. It is 97%. So this is the object detection algorithm which is going to detect the cell phone with 97% confidence. So this is the distance in inches. We have calculated 2 multiplied by 3.14 pi into 180 divided by w plus h into 360 plus multiplied by 1000 plus 3. So the distance is actually calculated by 17150 multiplied by t. So that's actually the first equation. If you see over here, the first equation, definitely it is going to give you the distance which is calculated in inches by camera lens with the help of the width as well as the height. Also the distance, this one is calculated by centimeters by ultrasonic sensor with the help of pulse duration as well as the sound speed. So this we are calculating with the help of equation 2, and this one we are calculating in inches. This one is calculated in inches, this one is calculated in centimeters. So detecting the multiple objects with various confidence levels from a single frame, we have a picture net data collection system which is going to train our model for the image categorization, and definitely we will have a bounding box around an item, and definitely we are going to determine its kind based on the data that we are going to feed from the previous example. So each bounding box we will have a softmax activation function and a cross entropy loss function. Definitely it will be assessing the likelihood to which class it is being present, and the model can use the backdrop object class in order to classify the specific objects. So every frame we will have a set of bounding boxes that can be identified using simple background classes, and for downsampling the convolution feature it is going to map to reduce the unneeded bounding boxes that is going to prevent this problem from occurrence. So this is the location tracking website I'm just talking about. So we are getting the location with respect to the each of the data that is being fed, and also here I'm showing you the location of the user with the latitude as well as the longitude. So with the latitude and the longitude I'm getting the GPS location, the exact location where we are observing the specimen. So I can summarize that it's a novel type of eyewear for persons who are entirely blind. So it's a now a pair of glasses even. So it's a sophisticated algorithm that can be executed on a Raspberry Pi model B plus. So we are experiencing like less computational power, and definitely with the help of the IoT based position monitoring, it can be used with ultrasonic sensors and IoT based location detection in order to measure the distance between objects. And today's advancements, definitely this technology will carry over maybe within the next 2 years or so. So maybe the people who cannot see completely can travel more efficiently, more comfortably, and with greater convenience. So these are the references I'm like to show you. So thank you for the opportunity that's given to me, and I'm sure you would have enjoyed much of the presentation, and definitely we can collaborate further to enhance this output for a better future.
Something fun. And sir, I have one doubt.
Yes, yes, ma'am. Yes, ma'am.
Up to what distance you have detected your obstacles?
Maybe we have evaluated with the case of the ultrasonic sensor. We have actually evaluated with the help of the test cases. So the actual one along with the the test cases, we have evaluated up to 12 sorry 30.2 was the distance. So up to a distance of 30.2, it was performing good even with the camera resolution of from 12 till 42 31, we are able to get a distance.